Well, uh, students, this is the fifth session of third unit. See, in this session, we are going to work out one of the problems pertaining to the constant pressure process. Before working out the problem regarding this constant pressure process, let us remember and recollect what is constant pressure process, what are the happening inside the system of the constant pressure process. Okay, energy supplied to the constant pressure process will be divided into two. One is stored as a internal energy, another one is used to do the external work. Then this process obeys Charles law. Then the third one, change in enthalpy is equal to mcp into T2 minus of T1, and work done is equal to P into change in volume. These were the information were given to you in accordance to the with the constant pressure process in the previous class. Now, let us look into this problem. Well, a quantity of the gas has a volume of 0.14 meter cube, pressure 1.5 bar, and temperature 100 degrees Celsius. Okay, this is the initial state. If the gas is compressed at constant pressure, okay, the pressure is 1.5 bar. This will not change throughout the process. Well, if the gas is compressed at constant pressure until its volume becomes 0.112 meter cube, determine. Okay, the initial volume was 0.14 meter cube. The final volume is 0.112 meter cube. Okay, if it's so, find the temperature at the end of the compression. Number two, work done in the compression of the gas. Third one, decrease in internal energy or change in internal energy. You take it change in internal energy and heat given out by the gas. Assume Cp is equal to 1.005 kilojoules per kg Kelvin and Cv is 0.712 kilojoules per kg Kelvin. These are the specified constant pressure and the specified constant volume, respectively. Okay, here the data given is written here in the simplified form. Okay, the pressure is given in terms of bar because here it is multiplied with the 10 to the power of 5 to convert it to the Newton per meter square, and the temperature is given in the Celsius. It has been converted into the Kelvin. That's what here uh, uh, 273 is added to the 100, and pressure we have to calculate the so pressure is constant, so final volume is given, and temperature has to be calculated at the final temperature, and what is the work amount done, that is to be calculated, and change in internal energy. So these are the informations which are given to you to find out the required askings. Well, see, we know that. So as I told you, the constant pressure process obeys the Charles law. The equation of the Charles law is what? Initial volume divided by initial temperature is equal to final volume divided by final temperature. So make use of this relation. You may calculate because pressure is constant over here. Uh, uh, you may calculate final temperature of the gas after compressed at the constant pressure. Okay, that is equal to after simplification, the rearranging, you are getting this form of the equation. That is equal to 0.112 is the volume, final volume of the gas. T1 is the initial temperature, that's a 373 degrees Celsius, and 0.41 is the initial volume. This is how the 298 0.4 Kelvin. This is the final temperature of the gas after compressing the gas at the constant pressure. And work done, you know this equation, you know the initial volume, you know the final volume. As usual, pressure is constant. After substituting all the values to this equation and simplification, you are getting the total amount of the work done because of the constant pressure compression. That is 4,200 joules or 4.2 kilojoules. Next, here we know this relation. We did derive the equation, how this Cp minus of Cv is equal to R. Say, by make use of this information, you may calculate the gas constant. The gas constant, that's the Cp is given and the Cv is given. After subtracting the Cv from Cp, you are getting 0.293 kilojoules per kg Kelvin. Then it is 293 joules per kg Kelvin. To find out the mass of the gas, here to find out the mass of the gas, this gas equation is used. P1 V1 is equal to mRT1. You know the P1, you know the V1. You know the gas constant here, it has found out. And M is the mass of the gas and T1 is the initial temperature. All the values are known. After substituting all the values to the equation and simplification, you are getting the value that is 0.192 kgs. This is the mass of the gas. But this equation also I did tell you, that is change in internal energy is equal to mCv into T2 minus of T1. As usual, Cv is the specific heat of the gas at the constant volume. All the values are known. There are the direct substitution. After substituting the values to this equation, you're getting the final change in internal energy of the system or the gas is equal to minus 10.46 kilojoules per kg. That means what? The system itself has given away the energy stored in it to do the external work. See, that what it is given in the minus value. And next is the amount of the heat supplied. Okay, it's a very interesting here. Look here, students. dq is the amount of the heat supplied. Say this is the equation which is using to measure the heat supplied to the system. Okay, is it okay with you? And dq is equal to mass of the gas. It has found out here. That's a 0.192 into this is the specific heat of the gas at constant pressure. It was written. This is the change in temperature. Okay, here what is that? The amount of the heat supplied is not sufficient enough to do the amount of the work done here. Amount of the work done here, amount of the work done here. The extra work has been done by the expense of the internal energy. The energy which was stored before in the system, that energy is also used to do this external work. Say that's what the value here is in minus. Okay, well, the after simplification and all, the value obtained is 14.77 kilojoules. Okay, if the internal energy is in the minus, that means what? The energy of the system stored before to this utilized to that process. If the heat supplied is in minus value, the energy stored or the heat stored in the system before the process is also used to do the external work. See, this is how you may work out the problems regarding the constant pressure process. Students, I'll tell you one thing. Before working out the problems, you have to make out the problems very clearly. Then only you'll come to know how easily you could work out the problem. Okay, with this information and with this guidances, I am concluding this session. Thank you. Thank you very much.